redstone system, let's switch the command type here from repeating to impulse and check this out. This is actually really interesting. Did you notice anything suspicious? Let's do the same experiment in Java version. Okay, I'm flicking the lever, whatever. You can see we can only see even numbers. So our first suspicion here is that regardless of the fact that the game runs on 20 ticks per second, the entire redstone system runs actually on 10 ticks per second, regardless of the cases. So what we have here, and that's my suspicion, is unlike in Java where every single action meets a reaction right away and it's organized in those ticks, and multiple events can happen even within the same tick, and we can control, for example, how pistons behave within the same tick. And that's how we can have those cool 0 tick and 1 tick contraptions. In this case it may not be the case, and to prove it we have another experiment here with water. So in Java, water spreads exactly 5 ticks per block. So in a second of water spreads exactly 4 blocks. And judging what I see here, it's probably the same thing. So here we have a little water channel, and here the dispenser can dispense water into this block, which can spread to the following blocks. And we have here 2 rows of observers, and those observers, one of them run into the command blocks, and we have our time query command block over there, and on the right hand side we have dispensers or droppers, whatever. And those are just to notify us orally about what happens. So let's listen carefully what happens if I send that water out. Okay, so let us hear this in Java edition. Anything suspicious? First of all, in Java it was very rhythmic, like tick 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 tick, because we have those 4 actions per second and they happen exactly 5 ticks apart. In Bedrock, if we have this 2-tick resolution, then the water spreads for every 5 game ticks, but the observers and dispensers can only react with this 2-tick resolution, and that's why we had on the left hand side, I can repeat that. We can either have 4 or 6 ticks apart. And if we listen closely, we have this written, it's not really even, it's like pa-pam, 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 pa-pam. Yeah, and this is actually a proof that the entire redstone system actually runs specifically on 10 ticks. And that's actually pretty mad, because in Java we could extend and retract the same piston or multiple pistons within the same even game tick and be able to very quickly move blocks and do stuff. Even within one game tick it was possible to do a lot of interesting things. Here nothing happens, like all the inputs are probably collected within 2 ticks, one after another. And then they're being processed and something happens, and then they are being executed after those 2 game ticks, which means that nothing can happen actually instantly in this version, even with observers. So everything happens, every event's inputs are collected for those 2 game ticks, block ticks, whatever, and then they are being executed or acted upon in this, what we can call here a redstone tick. Okay, so let's test here a little bit of the basic redstone timing things. So we have here, for example, repeaters, so what you'd expect, 2 ticks apart. All the other basic components probably you'd expect to work the same way. Next we have pistons. It's actually a very important change. So in Java edition they extend in 3 game ticks and they react to retraction instantly. So we have 3 or 0. And here in Bedrock we have 6 game ticks, so 3 what we call redstone tick. So that's twice as slower, and if we retract them, they are not instant, they are 2 ticks apart. So yeah, so this is much different than with Java edition. And what we have next is observers. Observers react instantly. You can see that all the blocks that change state, or at least they should have changed state here. There's just obvious cases they work. We can see that it doesn't actually react to the dropper changes. So what would happen if we would phase 2 observers into each other, which in Java makes a really cool and modern clock. So we have this clock here that ticks very fast. We cannot even see what it does. So if I put, for example, dust here, you can see that's always on. But see what will happen if I, for example, place an observer here. See, it actually stays on, and it's because of this one being kind of bugged out. See, I place another observer, they're on. If I turn this off, see, they're all on. Although this observer here, they actually work. So this is just a visual glitch, and it will go off after some time by itself.